All right, so again, I think we're around 28 or 30, something like that. Oh, just real quick, did we mention Fibonacci numbers? Okay, and just a reminder, have you seen those before in mathematics classes? So it's something that's kind of cool. It's basically just a sequence of numbers. It's like this mathematical, famous mathematical sequence of numbers, basically called the Fibonacci sequence. And they've got a little example program in the book that shows you how you can generate the Fibonacci number sequence, or figure out what is a certain number, in the sequence. So basically, the Fibonacci number sequence is the way to get the next number in the Fibonacci sequence is just to add the previous two numbers together. So if you look at the sequence there, once you get up to a certain point, like 1 plus 1 is 2, right? And then 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So you see the pattern there. 5 plus 8 is 13, and so forth. 13 plus 21 is 34, and it would just continue on from there. So, and like I said, they have a little example in the book that you can take a look at. But I'm going to kind of skip over it. All right, so this is kind of where we were, I think. I mentioned for loops. So a for loop is another way of writing a loop. They're really good for counter-controlled loops, but you can write other types of loops with for loops as well. But where you see them mostly is with counter-controlled loops. I mentioned you have three different parts of a loop. You've got your initialization, your test, your logical test, and then your update. So you're always going to have those three parts, right? And so with a while loop, those things could be spread out over your code. And so with a for loop basically takes those three parts and sticks them on one line. So for loops are really great as far as just being able to look at the for loop, that one line of code, and kind of seeing how the loop is set up, right? So the way that it works is you've got you have the word for, and inside of parentheses, you have your initialization part first. So whatever you're going to do there, and then a semicolon, and then your logical loop test, your loop condition. It's a logical expression there that evaluates it true or false, and then another semicolon, and then your update. Okay. So at the beginning of the loop, it's going to do whatever is in the initialization, and then it's going to test it. And then at the end of each pass through the loop, it'll do whatever is in the update part. So they're really good, like I said, for counter-controlled loops. So there's a little flowchart of it. So here's an example. What they say, the for loop prints the first 10 non-negative integers. So you see, this is a counter-controlled loop. They say for I is equal to 0, I is less than 10, I plus plus. So we'll start off at 0 and then test each time if it's less than 10. And at the end of each loop, each pass through the loop, it adds 1 to it. So what is that going to output? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then with spaces in between. Right. So anyway, those are for loops. Be careful when you're doing certain things like this. Just like with if statements, if you don't have curly brackets grouping anything together, like inside of your loop, then only the very next statement is considered to go with the loop. So you have to especially be careful with for loops. So if you have like two statements you want it inside the for loop, like on here, where it says see out hello and then see out an asterisk there, if you want both of those things inside the loop, make sure that you include those in curly brackets. If you don't, like on example 2, then even though it's indented, the indentation doesn't matter. Only the hello is considered to go with the loop. So on version 1 there, it will output hello asterisk, hello asterisk, hello asterisk, 5 times. But on the second one, it outputs hello 5 times and then the asterisk. because the asterisk doesn't go with the loop unless you put it inside of curly brackets. So just be aware of that. Also, here's another common mistake that I see, and this one, you don't get a compile error or anything on it. It just doesn't work right, and it's kind of hard to troubleshoot sometimes. So what's the problem there? So you don't put a semicolon at the end of it, just like with while loops. You don't put a semicolon there, so that semicolon on line 1, it's basically going to repeat nothing 5 times. And then it will output an asterisk. So be aware of that. So don't put a semicolon after your for line. You can actually just leave the 3 things blank. For this class, you're probably not going to do that. That creates an infinite loop. I actually use that I remember in grad school, we were writing some network communication programs where you had like a server process that would run and just kind of wait for a connection request or something, and we would do that. We'd just throw in that for loop with 2 semicolons in it, and it would just sit there and wait because it's an infinite loop. But typically, you're not going to do that. So your loops can go up, you can go down, like this one counts down, right? So the initialization starts I at 10, and then notice the update is I minus minus, so it's going down by 1 every time. And the test is I is greater than or equal to 1, so it's going to count down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then when I becomes 0, the test is false and it exits out. It doesn't have to go up by 1 or down by 1. It can go up by 2s or whatever. So this one, outputs the odd numbers. So notice the initialization starts I off at 1. The test is while I is less than or equal to 20, but the update part is I is equal to I plus 2. So it's going up by 2 every time. So the values of I will be 1, 3, 5, 7, 9, and so forth, and it's outputting I there. So for loops are great for counter-controlled loops like that. Okay, so that's a for loop. That makes sense? And I think we kind of skipped ahead anyway on Thursday. We were looking at nested for loops, right? So this should seem easy compared to that. How about a do-while loop? Have we talked about those yet? Okay, so the first type of loop that we looked at was a while loop, right? That's kind of like the most versatile type of loop. So a while loop is what we call a pretest loop. The test is at the beginning on a regular while loop, right? So you're going along, you've got your initialization, and then you have your test, right? If that test is false the very first time with a while loop, you won't do the loop at all, right? It'll just go on, it'll skip after the loop and go on, right? So the test is at the beginning on a regular while loop. It's a pretest loop. A do-while loop is another type of loop that C++ supports, and it's a post-test loop. So it's a lot like a while loop, except the test is at the end. And so with a do-while loop, it's going to go all the way through the loop one time before it ever tests anything. And if that test is true, it'll go back and repeat it again. But if the test is false, it will exit out and just go on about its business. But a do-while loop will execute at least one time, right? That first time it's going to go through the whole thing. And just about the time you get used to putting semicolons and not putting semicolons places, there's exceptions to the rule. So with a while loop, we don't put a semicolon after the condition part, right? But with a do while loop, you do. And I'm not quite sure why. Maybe because it's at the end. I'm not sure what the story is there. But anyway, notice that after the expression on a do while loop, you have a semicolon. Okay, I think I said those. Here's a flowchart version of that. So here's a little example. So what does this one do? So I starts off at 0, and then we go inside the do while loop, and it outputs I, and then adds 5 to it. So it's going to output 0, and then I becomes 5. 5 is still less than or equal to 20, so it goes back and repeats, right? And outputs 5, and then I becomes 10. So it's going up by 5 each time. So you see the output is 0, 5, 10, 15, and then when it's 20, 20 is still equal to 20, so it goes back and repeats. I becomes 25. But it outputs the I first, right? Before it increments it to 25. So when it's 25, it exits out. I think I said this already. While and for loops are pretest loops, meaning that the loop is at the beginning. It might not even go inside the loop at all if the condition is false initially. But a do-while loop is a post-test loop. The loop always executes at least once. I typically don't use do-while loops very often, but anyway, they're there. This illustrates that kind of the difference. So in version A there, that's a while loop. Notice that they initialize I to 11. And so does that loop get done at all? The very first time 11 is less than or equal to 10 is false, right? So it won't go inside the loop at all on A. But on version B, when I is 11, it's going to go through the whole thing. It's going to output 11 in a space, and then increments that to 16, and then the test is false. So a do-while loop is going to go through at least once. All right, so when do you choose the different types of loops? So here's some of this is the textbook suggestions. If you can determine in advance the number of repetitions needed, the for loop is a great choice for that. That'd be like a counter-controlled loop, right? If you do not know and cannot determine in advance the number of repetitions needed, and it could be 0, that's the key on that one, use a while loop. Again, the while loop is the most versatile. You can write just about anything as a while loop. For loops are great for counter-controlled loops. But if you do not know and cannot determine in advance the number of repetitions needed, and it's at least 1, you can use a do-while loop. All right. How about this? Break and continue statements. So we've seen this word break before. Where have we seen that before? You remember that? Remember the switch statements? So a switch statement was like a selection structure, right? And so we had the word break in between our different cases to separate things. And so the break statement would basically break out of the switch statement, right? And so it basically does the same thing with a loop. If you have a break statement inside of a loop, it will break out of the loop. Okay? And continue is a little bit different. It will actually skip to the next pass through the loop. But they alter the flow of control inside your loops, right? After a break executes, the program continues with the first statement after the loop or after the structure. They mentioned that a break statement in a loop can be used to eliminate certain flag variables. So we saw that last time, I believe. Like you can write a loop that has some kind of flag variable that when a certain condition occurs, it trips the flag, and then you exit out of the loop. So you can basically accomplish the same thing by testing that, and if instead of changing the setup of a flag, you can just have it break out. In the review questions, we're going to see a couple of examples. Continue can be used with while, for, and do while loops. So instead of breaking out when you have a continue statement, it skips the remaining statements and proceeds with the next iteration of the loop or the next pass through the loop. I don't think they don't have any. They've got a couple examples, code examples, I think, in the book. But like I said, we can look at some of the review questions in a little bit. All right. How about nested loops? So I kind of skipped ahead last Thursday. For some reason, I thought we had talked about it already. So hopefully I didn't lose anybody too much on that. So a nested loop is a loop inside of a loop, right? So typically it's usually set up where you have two loops, an outer loop and an inner loop. And usually for every one pass through the outer loop, the inner loop will probably go through multiple times, right? But you could nest them even more, right? You could have a loop inside of a loop inside of a loop or something like that. Here's a little code example that's similar to what we were doing on that review question that we ended with last time. You've got this outer loop that goes through 5 times, and then you've got an inner loop that goes through a certain number of times for every one time through the outer loop. And then there's an indel, so every time through the outer loop we're going to be going down to another line. But the inner loop is a little bit different because it's based on whatever the value of I is. So when the first time through the outer loop, when I is 1, the inner loop is going to go through 1 time. So notice on the output you get 1 asterisk. The second time through the outer loop, the inner loop is going to go through 2 times. So you get 2 asterisks. The third time through the outer loop is going to go through 3 times. You get 3 and so forth. So it makes this triangle of asterisks thing. This example is very similar, except it counts down instead of counting up. So you've got for I is equal to 5, and then notice the update is I minus minus. So, and then the test is while I is greater than or equal to 1. So it's counting down. So if you were to change the inner loop to that. So, oh, I'm sorry, it's the first 4 instead of it's the outer loop instead of the inner loop. All right, we'll look at some more of those examples in the review questions. All right, I think that's pretty much it. They have some stuff about debugging loops. All right, so I'm gonna